SQL injection. In this section, we explain what SQL injection is, how to find and exploit different types of SQLI vulnerabilities, how to prevent SQLI. What is SQL injection? SQL injection is a web security vulnerability that allows an attacker to interfere with the queries that an application makes to its database. This can allow an attacker to view data that they are not normally able to retrieve. This might include data that belongs to other users or any other data that the application can access. In many cases, an attacker can modify or delete this data, causing persistent changes to the application's content or behavior. In some situations, an attacker can escalate a SQL injection attack to compromise the underlying server or other backend infrastructure. It can also enable them to perform denial of service attacks. What is the impact of a successful SQL injection attack? A successful SQL injection attack can result in unauthorized access to sensitive data such as passwords, credit card details, personal user information. SQL injection attacks have been used in many high-profile data breaches over the years. These have caused reputational damage and regulatory fines. In some cases, an attacker can obtain a persistent backdoor into an organization's systems, leading to a long-term compromise that can go unnoticed for an extended period. How to detect SQL injection vulnerabilities? You can detect SQL injection manually using a systematic set of tests against every entry point in the application. To do this, you would typically submit the single quote character and look for errors or other anomalies. Some SQL specific syntax that evaluates to the base value of the entry point and to a different value, and look for systematic differences in the application responses. Boolean conditions such as or 1 equals to 1 and or 1 equals to 2, and look for differences in the application's responses. Payloads designed to trigger time delays when executed within a SQL query, and look for differences in the time taken to respond. OAST payloads designed to trigger an out-of-band network interaction when executed within a SQL query and monitor any resulting interactions. OAST. Out-of-band application security testing. External servers to see otherwise invisible vulnerabilities. Alternatively, you can find the majority of SQL injection vulnerabilities quickly and reliably using pub scanner in different parts of the query in different contexts. SQL injection in different parts of the query. Most SQL injection vulnerabilities occur within the where clause of a select query. Most experienced testers are familiar with this type of SQL injection. However, SQL injection vulnerabilities can occur at any location within the query and within different query types. Some other common locations where SQL injection arises are in update statements, within the updated values or the where clause, in insert statements within the inserted values, in select statements within the table or column name, in select statements within the order by clause. Okay. SQL injection examples. There are lots of SQL injection vulnerabilities, attacks, and techniques that occur in different situations. Some common SQL injection examples include retrieving hidden data, where you can modify a SQL query to return additional results. Retrieving hidden data, where you can modify a SQL query to return additional results. Subverting application logic, where you can change a query to interfere with the application's logic. Union attacks, where you can retrieve data from different database tables. Blind SQL injection, where the results of a query you control are not returned in the application's responses. Retrieving hidden data. Imagine a shopping application that displays products in different categories. When the user clicks on the gifts category, their browser requests the URL like this: https://insecurewebsite.com/products category equals to gifts. This causes the application to make a SQL query to retrieve details of the relevant products from the database, like select asterisk from products where category equals to gifts and released equals to 1. This SQL query asks the database to return all details, which is asterisk, from the products table where the category is gifts and released equals to 1. The restriction released equals to 1 is being used to hide products that are not released. We could assume for unreleased products, released equals to 0. This application doesn't implement any defenses against SQL injection attacks. This means an attacker can construct the following attack. For example, https insecurewebsite.com/products category equals to gifts, quote, single quote, hyphen hyphen. This results in the SQL query: select asterisk from products where category equals to gifts, hyphen hyphen, single quote, and released equals to 1. Crucially, note that hyphen hyphen is a comment indicator in SQL. This means that the rest of the query is interpreted as a comment. Effectively removing it in this example, this means the query no longer includes and released equals to 1. As a result, all products are displayed, including those that are not yet released. You can use a similar attack to cause the application to display all the products in any category, including categories that they don't know about, like category equals to gifts, single quote, plus, or plus 1 equals to 1, hyphen hyphen. This results in SQL query: select asterisk from products where category equals to gifts, or 1 equals to 1, hyphen hyphen, single quote, and released equals to 1. The modified query returns all items where either the category is gifts or 1 is equal to 1. As 1 equals to 1 is always true, the query returns all items. Warning: take care when injecting the condition or 1 equals to 1 into a SQL query, even if it appears to be harmless in the context you're injecting into. It's common for applications to use data from a single request in multiple different queries. If your condition reaches an update or delete statement, for example, it can result in an accidental loss of data. Lab SQL injection vulnerability in where clause allowing retrieval of hidden data. This lab contains a SQL injection vulnerability in the product category filter. When the user selects a category, the application carries out a SQL query like the following. Select asterisk from products where category equals to gifts and release equals to 1. To solve the lab, perform a SQL injection attack that causes the application to display one or more unreleased products. Okay. So if we go to lifestyle, if we go to lifestyle, there is lifestyle like this. If we do this, what do we see? Oh my god. Over HTTP.